Q3. Q1, Q2, and Q3. Now, green is negative. So this is negative. It's a negative charge. Positive, positive. Now, we want to calculate the force on Q3. You want to calculate the force on Q3. F net. I'm going to put a 3 here. That's what we're trying to find. Okay? So, in order to do that, zoom in. You guys please focus before I start moving you around. You should move it. Focus. Okay? My brain doesn't focus. Okay, so we want the force on this chart. That's negative, that's positive, that's positive. So first I need to calculate the force between this and that. Positive, positive. What kind of force do we get? So which way is it going to point?
Away from the other one.
Where?
Up and down.
Up.
I don't want
There's your force. And we're going to call this F of what? 2 on 3. Now we need that and that. What kind of force?
Attract.
So it's going to point which way?
Toward the, you know.
F of 1 on 3. We need to calculate those two forces. Calculate the magnitude of those two forces, right? Do that. This is my last example for the day. You should have enough information to go home and practice. We'll come back tomorrow. Come back tomorrow, being able to do one of these problems in its entirety. Tomorrow. Okay?
Is it going to be like this? Or is it going to be something that we didn't even learn? Because I don't like it when teachers do that. They teach you something, and then it's something totally different.
Okay, I'm not going to do that.
She's using her hand gesture, so you know she's.
I am not doing that, okay? So let's calculate F1 and 3. First we need to calculate F1, 3. Once again, it's K, Q what? 1, Q3 over, we need this distance, right?
Yeah.
What is that distance? 60 centimeter. So R, let's see, R1, 3. R1, 3, 60 centimeter or 0.6. You have to convert this to meter, ladies and gentlemen. 0.6 meter. So that's R13 square. Let me not put a parenthesis. Okay? So let's do that. Now if you want, you can just put it in there like that. R13. That's your R13. That's the distance between those two charges. Nothing has changed. Don't be confused by the diagram. Be disciplined. Okay? 9.0 times 10 to the 9. Newton meter square over Coulomb square. Q1. What did we say Q1 was? We didn't say, did we?
No.
86 microcoulombs. That's Q1. Q2 is 50. And Q3 is 65. Okay? So, Q1, 86 times 10 to the negative 6. Q2, Q3 rather, 65 times 10 to the negative 6 divided by 0.6 meter squared. Somebody please do that for me quickly. Thank you very much. And then we're going to do F23. Right here we need this distance again between the two charges. Let's call this R23. We need that distance. Let's see what it is. That distance is 30 centimeter. 30 centimeters, 0.3 meters. Okay? So for this one, once again, K, Q2, Q3 over R23 square, 9.0 times 10 to the 9, Newton meter square, Coulomb square, times 50 times 10 to the negative 6, times 65 times 10 to the negative 6, divided by 0.3 meter squared. Okay, did you get this?
I got 139.75.
139.7?
175, so 20.
Let's call it 140.
Okay.
140.
Okay, what about this one?
Sounds good to me. That one.
Second one.
I got 325.
What did you get?
325.
Okay? So we got those two numbers. Very important that we get these two. Well, basically, these are the magnitude of our two vectors. You with me so far? We've got the magnitude. Now we need to find the net force. Right here. We're only halfway done.
Oh my God. You're a joke.
Okay. So, based upon this, we've gotten up to here. We've gotten up to here. Now let's calculate the net force, which is step 4.
Sean, man, that ain't good.
No, there's late. Late one, man. That's January.
Look at my diagram.
Yeah. You went for early.
I need to know some of these angles.
Yeah.
Okay, this is 30, and this is 90, so this is what? That's 60 degrees.
What I did last Tuesday.
Don't forget that, okay? So,
Oh, even something interesting happened on Tuesdays.
I'm just going to deal with the vectors right now. The vectors. Now, let me draw this diagram right here. This is what I have. You guys please pay attention. Will you please pay attention?